Okay, so we are live and we are about to start programming. Alrighty, so I'm going to lower the music a bit. That way it's just not distracting. So, as it says, today we're going to be working on drawing diagonal lines, right? Now, this was actually a little bit of a thing I had to go ahead and do some serious reading, deliberation on, and brushing up on some math. So, anybody who's watching this, if you've played around with computer graphics before, maybe you've heard of Bressenham's line algorithm, right? Or maybe Shaolin Wu's anti-aliased line algorithm, right? But today we'll be doing Bressenham's. Maybe later I'll go ahead and try Shaolin Wu's algorithm. But today the objective is to implement Bressenham's. And so you can see I have my notebook to the side, Joplin, because I watched a video. It's a wonderful video by, I believe it's No BS Code. So go watch that guy. In fact, maybe I'll put a link to his video in the description because it's wonderful. Yeah, so, and I also read the Wikipedia article. And if you really wanted to, you can just go straight to Wikipedia article and just copy this, right? But I didn't want to do that. I didn't want to do that because that's lazy. It's lazy and it's... I want to use my words carefully here. I think it's ignorant. I don't think it's smart to just copy code. Right. You know what I mean? For example... I think that's how a lot of people, for example, mess up their Linux installations. Is they'll copy some code that some guy told them to copy, and then their computer explodes, right? It's not smart to copy code. Now, don't get me wrong, this is obviously not going to blow up your machine if you just copy and lift this code, but you should really understand why. It's a learning opportunity, right? That's how I saw it, at least. So I took time sitting down, trying to understand why this works, right? Because it's a pretty cool and challenging thing. Lines are continuous. They don't have to fit onto some discrete or finite grid of pixels. You just draw a line, right? We never think about it like that. So making an algorithm for doing that is, really cool. So yeah. Anyway. So I wrote notes, and of course, after I understood everything, I put it in a very straightforward C function, right? One that's kind of a little bit friendly to my my encoder, right? Using uint32s and all that stuff, right? But of course, obviously, so I think so the issue here is that there's this plot function, right? And I'm not gonna just have a function call a function. That's also really ignorant. Like, just all the usage of the stack tearing it down is just stupid, right? Because placing a pixel is relatively straightforward. It's really just a matter of I need to get the scan line, but the scan line pointer should be very straightforward. Now that I understand, it's really just multiplication, right? We just multiply an attribute that I store in the BMP. It doesn't get written into the file, but my struct has a thing called I believe with without, it's either like with in bytes without padding and with in bytes with padding or something like that. So okay, if you multiply it by 0 for scan line 0, because I count by 0 in my implementation, then we get the scan line, and so that's how we access, for example, our y, right? And then we offset, which is super easy. So drawing it is pretty easy, man. Now that I have this and understand how this function works, and it's kind of weird. Like, again, you may have seen on the side I had all this math stuff, but basically this entire implementation here is just based on so if you're taking a physics class, it's like derivation, right? They have some set of equations initially, and they simplify them and address something. So, for example, in a naive implementation, you might use the slope, right? But there's no slope, right? The slope is a floating point number. Often you're going to get fractional positions, and there's no floats, right? This is a finite, discrete grid of pixels. So, yeah, for example, you can see how the slope gets transformed into something else where we're only working with integers. And so it's really cool, and it results in this really fast line drawing algorithm. And they also have it, apparently it's even used in hardware by graphics cards and all these things. So it's really cool. And today we're going to go ahead and implement it, right? So, now I think also behind the scenes I had improved some other things just to the quality of life, but something important. It doesn't really pertain to the nitty gritty development of something like this, right? It was more I improved my build script and some other stuff, right? So, anyway, now what we're going to do is add the Bressenham's line algorithm to our draw line, right? So the draw line function is able to infer what sort of line you're drawing, right? So for example, here we have this case is for the horizontal line, this case is for the vertical line, and this case is for the diagonal line, and it's not finished. And earlier I was doing the exact problem, right? Here you can see I'm using the slope and stuff, and but you don't have to. Using the slope is I won't say ignorant. It's just, but it's naive, right? It's there's a better way to do it, and that's exactly what Bressenham did. In fact, one moment, I want to see who was. Let's just go pay credit where it's due to the man who gave us this algorithm, because I mean, without it, we owe to him all sorts of stuff in terms of graphics. So one moment. So not much is written about him, at least on Wikipedia. But this is the man to whom we owe this algorithm, right? Jack Elton Bressenham. Was born October 11th, coming up soon, actually, in Clovis, New Mexico, the former professor of computer science, right? And also he served 27 years of service at IBM, so 16 years at Winthrop University, and he has 9 patents and 4 children. So, yeah, I suppose he's still alive. It doesn't say anything, so wonderful, right? Well, thank you to this man for the algorithm, and today we're going to implement it. And actually, later, we're going to do this one as well, because shapes are more than just rectangles and squares and triangles, right? And those will be the first ones that I'll tackle, but of course, we got to draw circles as well. And, I believe... Yeah, so... this is actually based on his. So again, without his work, too, it calls into question the domino effect of the inability to develop this, but it's based on his line algorithm. So yeah, very cool. All right, so let's go ahead and implement it. Right now, one thing I definitely do want to do is I want to change this to more resemble points, right? So I want the order of the arguments to follow points, right? So I want it to be like x1, then y1, and then x2, and then y2. I don't want it to be what I was doing previously. I don't know why I was doing that, honestly. where it was like x1 and then x2, and then you know what I mean. So I'm changing this now where it's going to, and so this doesn't change anything in the implementation of the function, but it's more for the program I use that makes use of the library, right? So that's just one thing. I think that's more concise, right? You can think of it as coordinates as opposed to whatever. I think in a previous stream I was trying to figure out where I wanted to, how I wanted to provide the coordinates, and I was having a problem, so I was just trying to wrap my head around it. And it was obviously much easier to just give them as XY coordinates as opposed to like XXYY. That just made no sense. All right, so anyway, diagonal line. So I'm going to take this code. I wrote this in my notebook, so this is my code. Based on that thing Wikipedia after I wrote all these other after I wrote all these other damn notes, right? With some screenshots from NoBS's video, right? And yeah, so NoBS Code did a much better job at explaining it than I could in this video. Well, in this live broadcast, right? So I'm going to kind of explain it off the cuff as I implement it, but I'm not going to give a full like lecture on that because it would just be disrespectful to the viewers and it would be a waste of time. Because I'm not going to do as good of a job as that guy. So, please forgive me if that's what you were looking for. But seriously, do yourself a favor in that case and go watch No BS Code's video. That guy's video is excellent, and that's how I learned. So, yeah. Alright, so let's go ahead and do this, right? So actually, I'm just gonna get rid of all this. Right? Now, this part is A-okay. Well, actually, this part can go away, too. This part doesn't exactly matter. Yeah. I think what really just matters is, so, you know, there is the idea of the octants. But I think all that matters is that, really just that you pay attention to, this, right? You want to swap them. Yeah. Actually, so I'm not using this implementation. I'm going to really use this implementation instead. Alright. So, once again, now I think, I think pretty much, yeah, no matter what, this check happens. So I think I'm going to perform this at the top, because it's going to happen no matter what. I don't think that should affect anything. So I'm going to take this and put it here, right? Okay, so this is how much it gets in. It just looks like it's indented a bit too much, but whatever. And this too, right? Now, of course, this is using swap and pixel offset, which means that they need to be defined already, but they're not, based on the positioning of this. So I'll put this above here. But then also, the scanline pointer is based on the value of y1, and we want to ensure that y1 is less than y2. So we're also going to do this, right? And put it here instead. Alright, so this kind of forces it to kind of be doing left to right logic always, right? Left to right and bottom to top. I believe. Alright, so anyway. Then what we're going to go do is we're going to go here, And swap is already defined, so that's whatever, right? So skip all that. Alright, so now we have our idea of delta x and delta y, and this is what's called the decision variable. An decision variable is basically you are deciding whether or not you need to change your y position. So, when you place the pixels on a grid, you're placing them. X is incrementing, right? Supposing you have a broader line as opposed to so a line with a shorter slope as opposed to a steeper slope, right? In that case, you're iterating over x, and then x, as you move along x, you're kind of getting a little bit of error accumulated in the y, where you really should be placing down the pixel at like either a higher or a lower pixel so that you're getting the most coverage of the line, the true geometric line. All right. So it starts off at 0. But anyway, this is called the decision variable. That's why it's D. Some implementations call it error or whatever, right? And you're gonna see here that we're going to multiply it. We're gonna set it equal to this, right? So initially, it's 0 initialized, but we're gonna set it to this. And the reason it gets set to this has to do with the derivation I was talking about above that I wrote in LaTeX in this note page, right? But that's really beyond the scope of this right now. Again, if you want to understand why that is the case, you should go watch No BS Codes video. That's No BS, not VS, like VS Studio. I will never use that. No BS Codes video on the Bressenham line algorithm. You should watch that if you really want to understand why that works mathematically. So yeah, let's go ahead and do this, right? Alright, so this is what I was talking about with a line that kind of goes more across, right? So, for example, if your line looked a little bit more kind of like this, I guess. This is the idea of the line is mostly broad, aka horizontal, right? So the line doesn't have a steep slope, right? Whereas a line that has like a very steep slope might look more like this, right? And that's a different case. It basically just matters what we're iterating over, right? Because here you can see that there's much more change in y than there is in x, right? And so, for example, and this one has much more change in x than there is in y. So that's why here I'm checking for whether or not the delta x is greater than delta y, right? And by default, if they're equal, I'm just going to handle the delta x case, right? And so case here, of course, else is just being okay. We're going to go deal with the steep line, right? In which case, we're going to be iterating over y instead of over x. All right, so now, this is a little bit weird. Earlier I forced the greater variable. So earlier I forced such that when dx is so this should really never be negative. So I don't know if this direction thing is required anymore because I just forced I forced it to always be positive. So this is weird. It should never be less than 0. In fact, I don't know. Did I correct that myself, or is that part of this thing? These people are doing something weird where they have like a plot low. So I believe this is like mostly horizontal thing, and this is the high for the steep. I just think this is kind of dumb, like calling these functions and everything, right? Um, So yeah, I don't really even know where I don't really know where I got this direction thing from. I don't think it's required though. I'm definitely also not seeing it here. Right? I think this is really just more that it's iterating over uh, X instead of Y. So for example, we can see here, uh, you know, eh, how stuff gets swapped out. So here it forces the um, greater value. So if X is greater, if X0 is greater than X1, eh, then we actually start with X1 instead, so that it's always going in the left right direction, right? And same thing here, right? So if the initial point is greater than the end point, and then we're just going to go ahead and use the end point as the initial point instead. So it's the swap, right? But that's just kind of, I don't know, I just don't like that. So I'm going to do a little bit differently. Just want to see, and of course, so that means that plot line high should be iterating over y, right? Yeah. So, all right, everything is cool over here. I can get rid of this direction thing. That's not needed at all. Dope. So, yeah, direction is just doesn't need to be there at all. It's not a real thing. All right, so then of course, change in x can't be 0, right? Because otherwise, that's just I don't think that's even possible. Because yeah, earlier it should have already been caught that dx can't be 0. Because I've already have a thing over here. If dx is 0, then I'm drawing a vertical line, and a vertical line is fine because this is not only for drawing. My function is not only for drawing diagonal lines. My function is for drawing any sort of line. So earlier I checked if dx is 0, right? Which is basically this, if x1 is equal to x2. So I can also remove that. That part from the notebook is actually irrelevant, right? So that part's going away as well. So actually, we basically just got rid of these instructions and these, right? And now we're going into the meat here. So right, that's where the put pixel would be, right? And as I said earlier, we have this because that, according to the derivation that Bressenham did, and this is always the initial value of the error, right? And then we had this idea of the decision variable, what happens when y increases, and what happens when y stays the same to update the values, right? Those two had a common factor. The common factor is this, right? So whether or not y changes or y increases, for the next iteration, the decision variable should also gain 2 times the overall change in y, right? The non-common factor was that if y did change, which is actually is a snake, this says p instead of d, but if y did change, in other words, if the decision variable crossed some threshold, then yeah, so then it should do this, right? Now it can't be less than 0 right now because it's what do you call it? An unsigned integer. So I need to actually change that and make it just an int 32t type, right? Alright, so then here's this idea of putting the pixel down, but I'm not going to be doing that, of course, because that's irrelevant, right? Well, putting the pixels on a function, putting the pixel is a matter of accessing memory. So we're going to do that in a second. Let me just write the skeleton right. I'm trying to think. I don't know if doing that swap thing mattered. Like if it can have unintended side effects. Okay, so for example, let's say our points are like this, right? Is that the same thing as we're both needing to swap, right? Because this line is going 3-7 is across and up, right? 1-5 is down. So this line is like positive, right? And let's say instead I had which would then become okay, so this line would be going down. But this line would be going up. So I don't think we can just flip it like that. Yeah, we can't just do that. Those are not the same line, I think, right? I don't think those are the same line. Yeah, I don't believe that's the same. One sec. Yeah, those are no longer the same line, right? So that can't be done. So actually you have to use that direction thing. And that's fine. So, let's see. Yeah, so this actually can't just be here, right? Now, it's okay for the horizontal line, because the horizontal line has constant slope, right? It doesn't really matter. But this does matter. Yeah, because I wanted the vertical line to start drawing bottom up, right? Okay, so that's fine, but yeah, so we do need to use this direction thing here, which means I can just go ahead and put another in. Right, so we can just put that there. Because of course now then I need to work on direction, right? So cool. So that's the broad um, function implemented just like that, right? And yeah, so now actually it is possible that dx is no, dx still can't be zero. That's still not possible because that would already been caught, right? So we don't have to deal with this guy, but we did indeed have to deal with that guy, right? Cool. Well then, so the first pixel always gets plotted just fine because you're already given the coordinates. So anyway, let's go ahead and plot the pixel, right? So I think scanline pointer should be defined always, no matter what, because it's before all this like if else logic, right? So we're going to do a basically y times width in bytes with padding, right? So if y is 0, then we're going to get just a start, so that we're on the first scan line, right? If y is 1, we're going to get the next scan line and such, right? So that's the scan line pointer. And we want to write data plus the offset, right? Now, I think the offset is already also a variable that's defined for all of these cases to use, right? Yeah, pixel offset. So here then the pixel offset is going to be 3 times I, right? So then we just put our RGB values. So I'll put green here, and then I'll put red here, right? And I think that's it, right? So that's the case of the horizontal line. I think that should work. I hope it should work. And so otherwise, if we're not doing that, then we're dealing with a mostly vertical line, right? And it's basically just this logic, but using y instead of x, right? So, or sorry, I misspoke. Well, we're using dy, but we're changing x instead of y, right? So now the direction can also be negative for x, right? So we're going to do that. But dy can't be 0. We already know that because that would be a horizontal line. It's already captured, right? Now we have our temporary x variable. And I believe, yeah, d is already defined for us to use. So here we're just going to go ahead and put an x on the stack instead, right? So then now we're going to set the d doesn't have the same equation in both cases. So here you can see that it's 2 dy minus dx. But here actually instead we have 2 dx minus dy. Cool. Okay, so now going to just do our loop, right? So and that's it. So now this should return a pointer to the next byte that would be written to. And that sounds kind of fucking annoying. So anyway, we still have the same considerations, right? So in that case, it could return. Okay, so the line can end on a boundary, right? It can reach one of the upper bounds. In which case, there is no next pixel, right? Because it's following the logic of if the line were to continue, right? So what we're going to do then is I mean, the equation can just be extended, right? It would just be the next. Then you have to do the D logic again, and I just kind of don't want to do that. It's just kind of annoying, right? And also, in practice, I don't exactly use the return type. So, and I really just kind of want to get to drawing the lines and seeing if this works. So I might just cheat out and have this return the final pixel that it used. But let's see. Um, well, we still never finished this anyway, so this one needs to plot the pixel. So let's have this plot the pixel, right? So of course we're going to get our scan line pointer. And that's going to now, it's still going to be y, right? We're iterating over y. So in this case it's I, right? That's kind of weird. It's going to be I times BMP width in padding. Width in bytes with padding, right? So then the pixel offset is going to use X instead this time. Instead of I, right? So we have our X, right? X is 0, and then it should be getting set to oh, that's weird. It shouldn't be 0, it should be set to X1. There we go. So X is going to be 3 times X, right? The pixel offset is going to be 3 times X. And so then we're going to go ahead and put the value. So we're going to do There we go. And I believe that ought to be the function. Let's just do the return types, right? So, um, honestly, why doesn't the function just return where it left off? No, well, here, fine. Let's do the broad one. The broad one is easier, I believe. So here we're increasing y, right? So if y is greater than or equal to um, the height, right? Because the height can't be touched. You can't use if you have a 256 by 256 picture, you can't use row 256 because the rows are actually ordered from 0 to 255, right? So okay, otherwise we're just going to go ahead and return. I guess a hmm. In this case, y increases by direction, and x increases by 1. So I guess that we're just going to find the offset for x plus 1 and y2 plus direction. So yeah, so actually that wasn't too bad, right? So I guess we can just follow the same logic here. Basically, just copy this. Um, yeah, basically, they don't use the exact same logic because I have to increase either x or y uh, by direction. So they both can't use that where it's just like that. But yeah, so this is still the same thing. But now it's more like if y2 plus 1 because y is iterating, right? And this is more like if x. Oh wait, why am I increasing by one? I think usually what I'm supposed to do is check the width -1, I believe. Because we're talking about where it ended, not where it would be continuing from, right? Yeah, we're doing where it ends and then decrementing. So let me just change that real fast, right? So it's more like there we go. And yeah, so it's more like if x is at the boundary, right? It's where we ended off. Okay, so now then, it would continue with um, x plus direction, right? Oh, I know. It would be y2 plus 1, right? And then this would be more like 3 times x plus direction, I believe. I think that's correct, and that's also different. This is y2 plus direction. Instead we're doing y2 plus 1. And this is x2 plus 1, but instead we're doing x2 plus direction because it flips. I believe that's correct. Anyway, so this, though, is wrong. If x2 ends the boundary, and same thing if y ends the boundary. Well, it's more like if y2. Yeah. Okay, cool. I think that's done. I can probably compile this now. Okay, so I have a simple error there. And I have a bunch of, yeah, so line 277 just has a typo. Um, and then 313 has a typo, so 277. What the fuck? Oh, okay. No, it's 313. Alright, cool. So it does compile. We just have some warnings, right? So from UN32, uh, in 32, yeah. So I think somewhere I forgot to somewhere I changed it to a signed integer, and then I forgot what I was doing, and it became unsigned again or something, right? Yeah, is it? Did I redefine it or something? Wait, I don't see what the problem is. It's a signed integer type. In32T is a signed integer type. So what is the problem exactly? Okay, so I get that these are not used, right? But where did the problem start here? Yeah, that's fine. I don't care about the put pixel. Okay, so it can never be less than 0, because it's unsigned, right? Um, okay, I see now. So, and we know that they're not the same. So yeah, so these guys shouldn't be unsigned. They should be signed. Not that the difference would ever be so great that, or at least so I believe, that an int 32 is not good enough, right? Let's see. And the x coordinate can never be negative, so I think it's okay that, for example, the x and the y are made to be unsigned. Well, there's definitely less warnings now. Um, like it's really just right now it's mostly unused parameters. That's fine. Um, I don't see why that would be the case. Um, I understand that x2 and x1 are unsigned, but just subtract those as okay. I guess I need to put typecast in front of this, right? Ah, yes. So the problem with this is that I forgot. So here I forgot to have the scanline pointer. Uh, this is all to be added on top of the memory address where the pixel data for begins. So that's the problem there, and that's 250 stuff, right? And 238 is where I get to the sign silliness, right? So I believe what I need to do here is this. I hope is going to make it happy. Cool. Um, and yeah, and so scanline pointer stuff is a problem. So this all should be racked up in parentheses, and then I can put. Yeah, this all needs to be an offset of the pixel data. So similarly, this is not correct either, right? And same, no, so vertical line stuff is okay. It's just I needed to make sure, so this is okay here. For the horizontal, where now I'm actually using that. And then here, once it goes to return it, that's cool. And then we need to do the same thing here. So this is incorrect. And same thing here, right? Cool. Let's clear and then recompile. So we still got a bunch of warnings, but I think most of these now are unused parameter. Now I'm still getting hmm. Okay, I see. Uh, I think at that point then I think I would just rather make long term is actually it has to be okay. Like if you want a whole lot of pixels in your thing, then okay, what is it? Yeah, I totally see too. What the hell? One sec. One sec. Okay. So, I think this is good now. Oh, wait, no. Because, yeah, it's getting mad about the sign potentially changing, right? Uh, Now, I can't just go from unsigned to signed, because it's potentially too much. Uh, so I think what I'm going to do then, I can make it size T, but it's also not exactly good either, I think. I don't know if people are exactly making like million pixel wide images anyway, so I think in 32 is okay. It's just that obviously, you can't have a negative pixel, right? Uh, and that's why I was using uint in the first place. Um, so I almost feel as though I can ignore those warnings, right? Um, Maybe I can just, I don't know, maybe I'll just cast them. I just feel like there could be like loss of data there, and I don't feel like having to check. Um, what if I having to check this thing and be like, hey, no negative coordinates. Just so let's see. Maybe then my program will need to typecast both of those two. But I think then it's going to tell me the same thing, where I'm potentially losing um, the value potentially changing if it's too big. Oh, okay. I guess not. It stopped caring. Well, anyway. So apparently I'm doing a conversion from an unsigned integer to an integer with the sign of the result. Okay, yeah, so direction could possibly be negative, but I think I made y unsigned, right? Now, it should really never be less than 0 anyway. Um, so I feel like that's fine. Uh, yeah, I don't exactly care that y might become negative, because we're never going to place on a negative pixel anyway, because, y should, never be negative. It should always just like that. At smallest, it should be 0. So I think I'm about to start ignoring these because this is just sign conversion, right? Um, let's see. I just don't want to do a whole bunch of if else, right? Like it's convenient that direction is negative. I don't think there's any way out of it. I think I need to check. Um, I think I have to check the value of y no matter what in this case. Like for example, I have to check that. I'd have to check for direction, or I need to check for if y is in 0. But either way, I'm doing branching on every loop. I just think that's not smart. I just don't like that. Um, Although I also don't know if it matters. Like, it may change the sign. Um, I just feel like I can ignore that. I don't think that actually really matters, right? So let's just ignore that for now, right? So now then, because I changed these where they come first, right? So this is a horizontal line. So I changed these where the x and the y come change, right? So since this is horizontal, the y stays the same. Um, there we go. So um, y is unchanging here. Um, so this is from, okay, so this should be 255, and this should be I, right? Now this is a vertical line, which is why these stay the same. So I think that, what, this should be I, and this should be 0. And then since this is also a vertical line, x doesn't change, so I guess the x2 should be that, and I'm going from 0 to the top column, right? And now I'm drawing these lines, right? And they're all horizontal, so I guess I can do I here, and then 245, right? Cool. Now I have, this is going to be diagonal line example. And I guess what I'll do is I'll just draw a diagonal line. Uh, so right now we have like two squares, right? Outer square is a darker color, and the inner square is a lighter color. It's like blues, so I guess I'll just draw white, right? So I'm just going to draw 2 lines, right? Let's see. So the first X position would be basically where this line begins, right? Um, so at 10, um, and this will be the one that goes up, right? So its starting Y would also be 10. Um, its ending X would be 245, and its ending Y would be I don't know, what, 245 as well? Doesn't go all the way to 245. That's where the border is, right? Okay. So this doesn't go to 245. This goes more to like 244. I guess the Y is 244? Well, yeah, it should be perfectly linear. It will perfect. It's going to be a 45-degree angle, so I think that makes sense, right? Then conversely, this one would start from 244, 244, or no, this would start from 10, 244 until 244, 10. So X goes across, right, but Y goes down. Yeah, okay, cool. I think that should work. I hope it works, right? So, oh, because I didn't provide the color. Silly. Yeah, so I said the line should be white, so all the values should be maxed out. Okay, that was cool. Let's run it. Let's look at our pictures, right? Well, judging by this preview, looks like it worked. Let's go ahead and open the photo in Gwen view. Yeah, would you look at that? I got diagonal lines, right? Doesn't quite go to the edge. So I guess I drew this wrong, where this should be thicker, I suppose. Uh, but yeah, I mean, that's cool, right? I mean, I just drew these lines, right? So now, of course, then we can go ahead and draw shapes, right? Uh, let's see. Let's try putting a slightly more what do you call that? Like steep line, right? So I don't know, maybe like go ahead and put like two triangles in here, but like two weird triangles. So I'll put like another line, right? Okay, so why don't we just start at 10 again? Start at 10, 10 again. But no, so yeah, and then we'll go from, I don't know, let's go a few pixels across. Middle point is going to be like, if it's 10 to 244, then it has a distance of what, 235 or something, right? It has a distance of, sorry, that was ridiculous, of 234. Right. So 234 divided by 2 is like, what, 127? No, geez, man. 117. So I guess I'll have this go to like 117, I guess. And I want to have the middle height between these two things. So it's 10 pixels raised up, I believe. The whole thing is so 20. Alright, 256 minus 20, 236. So the middle point of 236 would be like 2. That would be 118, right? So I guess the 118 doesn't really sound right, but whatever. Just draw that line. Let's make that line also white. Okay, well, it drew the line, but I don't know what the hell happened. I thought I provided the right coordinates. Yeah, what went on there? It starts at 10:10, but then it starts, like, seriously freaking out. Yeah, I wonder what happened with this line. It doesn't even seem to have started at 2:10. I mean, at 10:10. Might just, I'm not seeing it right. Like, let me make it black, or is it just because of the way the slope is, where it doesn't really like fix itself for a little bit, or okay, well, that's why. The slope is about the same, so I guess I just need to have a more drastic slope, I guess. So I guess let's try a more drastic slope, I guess. Let me zoom out a bit. So we'll go from 10-10, but I guess to like uh and 118 wasn't high enough. Looks like we need to go up more like 5-ish, or like I don't know, like 123, I guess. Um but we'll have it do this like let's just have it go all the way to the top, I guess. Let's just have like, something kind of weird going on there, I guess. So let's actually just have this go all the way to eh, what is the height that it stops at? The height that should stop at is 244, right? Just draw a black line so it's super easy to see. Okay, cool. Well, the thumbnail is showing, but not actually on the thing. Wonder why. Oh, here's the photos, right? Cool. That's what I wanted to do. Okay. So let me just go ahead and do the mirror, right? And I think with that, then we can call it done on the diagonal lines thing. The only thing would be to later add anti-aliasing, but for now, I think it's pretty cool. So let me go ahead and can I call Gwenview? Can I just call Gwenview from here? I was gonna do that instead of just opening Nemo a bunch of times. Okay, so let's just draw the opposite of that line. So I guess that would be from the other end. Right, so I guess now we would be at, what is that? We would be at 244. Oops. Oh, I know. We would be from 244. I'm not losing my mind. From 244 to 117. Right. Um, and it goes from 10 to 244, and that's still correct, right? I hope so, at least. Okay, I don't know what happened, but I guess I didn't do it correctly. There we go, but not exactly the correct direction. It looks like X should have been decreasing instead. So I guess now we can just go find out why that happened. So its instructions here were clear. I guess maybe I need to do, let's try 244 to 117. There we go. So I guess it's just being a little bit weird about it's just being a little bit weird about yeah, what do you call that? The positioning, right? I don't think it wants me to swap stuff around. 'Cause I think I was swapping stuff around, and that kind of gave me my problem. I just wonder why it's a little bit off center. What number would that be? It should be like 10 wide. This whole thing is like 235 or something, I don't know. Well, anyway, it looks to me like diagonal lines are a thing now. And that's cool. Because that's what we wanted. So I guess the live stream is done. I think it was a little bit short, it was a little bit faster. We kind of got through this, right? Well, this time I came prepared. I had my notes and everything. So yeah, that's super cool and super fun. So now the next live stream can tackle something that's pretty cool and pretty fun, I think, and that's drawing shapes. And then another thing we can do, and I might actually do that before, is I'm going to make like a scripting language, but like in I guess in well, no, not scripting. Jeez, like a data definition language, like sort of, I guess. So instead of like, for example, writing um in this easy BMP file that I have, I think it'd really be better if it could kind of read a file that defines the picture, like YAML or something, kind of do. The reason that this kind of idea came across me is because I was watching videos about Nix OS, right? And it was how like you can define your operating system, using I guess like code, I guess with your like Nix configuration file and stuff. I think it'd be cool that instead of like having to write a program to interface with the library, I could just write some plain text, right? And then the EasyBMP thing takes the plain text and renders the image based on what I described. I think that would be cool, right? It also then lets you, I guess you can kind of call it portable because the way you generate the photo is textual data. That it could be just like a couple of bytes long, right? To then get a bigger picture. I think that's cool, and I think it would save me time. Because then it's just a matter of I don't have to keep recompiling EasyBMB. I can just change the definition file it's using. So I think I'm going to do that. And also, it lets me do a little bit of extra fun stuff that I like, which is parsing, right? But anyway, this language example would be language. It's really like a very primitive thing. But I think it kind of be like this, right? So you say, um, like subject, right, and then data. Really, really simple, right? So I guess you would say I want a pixel at these coordinates, right? And everything's just space delimited, and then here would be your RGB, right? So let's just say you want it white. So then again, similarly, you can just do line, right? Something like that, and you can just put a bunch of these, right? And so in the next live stream, I want to do shapes, right? And so the shapes would just take 4 vertices, for example, right? So 4 coordinates, right? So let's say I wanted a square, right? Now a square could be actually you could provide just 2 coordinates if you want, because it gets filled in automatically. Once it knows that length, it's easy. So actually, square could just be, you know, eh, as long as they're not like diagonal. I guess one limitation would be that it either has to be on the exact same. Um, like let's say you shift the x-axis up, it has to be on the x-axis, or have to be on the y-axis, right? Suppose then we move over the y-axis where it starts based on your initial coordinate, right? So then you can kind of do like a, say you want a square at 10, 10. And so let's say the x has to be the same, right? And 10, 15. So then it could fill that out because it would know uh, that all it has to do is go 5 pixels across, right? So that's the thing I'm thinking about too. Now, rectangle is different because I think rectangle needs to have all 4 vertices, right? So rectangle, and I guess, just for making it easier to write, you can also, I guess I could also have it take this kind of thing where this is what it expects after certain keywords. That way, I think this is cleaner to read, right? As opposed to like all these numbers. Um, so I think that's going to be part of like the data definition language, if that's even the right terminology to use here, right? And I guess the RGB stuff can just kind of be plain like that. I don't know if people think of RGB as like coordinates like that. I guess and you can also try like write RGB. It's kind of getting to like some ugly. I mean, I guess it's more concise that way. Maybe I'll leave it like that. Yeah, and I guess it doesn't have to be on new line. I guess you could terminate with a semicolon if you wanted to. Um, yeah. And then honestly, I guess if you really wanted to, you could get more like do like some simple bash stuff where it's this, you know what I mean? I can also just have it handle all of these as well, right? Then you can use like a curly braces if you want, or if it's like a set of coordinates, right? Or you can just do just parentheses, right? You can do like a list by putting a bracket. I think these are all things that are probably easy to handle in terms of the parsing, right? Like for example, it would have to just search for this token. Um, just hey, RGB equals. That's not even hard to do. Semicolon can be there or not, if you want. You can say chords if you want, or coordinates, right? And I guess this would require all the coordinates, like I said earlier, for the rectangle. I just don't know if that is getting maybe we can get nuts too, I guess, where it could be like individual pixel placements, right? So you can say something like, um, I think this is like how YAML does it, right? And at that point, you don't even need to put pixel. You can just put like the coordinates, right? Um, so like this, I don't know. So that's kind of where my inspiration and ideas are as far as like the language design would go there. But yeah, uh, that might actually even come before the shapes. Shapes will be super fun, but I think it'll be like way more fun to do shapes by using this like language thing instead. Although I also feel like for the series continuity, it's kind of weird to have this like side step, or because this doesn't necessarily have anything to do with writing a BMP encoder. So it's like you get through parts 1, 2, 3, 4, and then part 5 is like not necessarily related to it. I don't know. Maybe I just have to make like a video or make it like a step 4.1. Um, or maybe I can just preemptively put like part 6. Like if part 5 is shapes, right? Well, part 5 is probably gonna be like regular shapes, like non-round shapes. So like square, rectangle, pentagon, shit. You know what I mean? Triangle. Part 6 probably be circles, and I guess that would leave part 7 to be like the data definition language, the markup language, right? Um, so I guess what I can do is I can just do the markup language anyway, preemptively call it part 7, and then retroactively, like Star Wars, do parts 5 and 6. I think that's my plan. I think that's how I'm gonna make it work. Because yeah. Now it's gonna be weird, I guess, if anybody comes back and watches all the parts, which is so many hours, right? In part 5, then they're like, what is this? What is this guy? What is this file he's writing, right? But so I guess at that point I have to say, oh yeah. So if you're watching this, by the way, late, you go watch part 8, go watch part 7 or whatever the hell it is, right? Yeah, that's funny. Well, anyway, I thank everybody for watching. You know, like and comment and subscribe. I guess all that stuff that YouTubers always feel compelled to say for whatever reason. But yeah, seriously, I hope this was enjoyable for anybody who watched it. I had a lot of fun. This is a very fun project. It's actually my first dive ever into computer graphics at all, and I'm kind of doing it like, I'm not really doing like the real man computer graphics yet because I'm just generating pictures. I'm not even doing anything like directly to the screen that you see. I'm not doing like a game engine or whatever. But uh, anyway, I'm still having fun. So yeah, well, that's the end of the stream. And again, thank you for watching.